Hello everyone, and welcome to this video where I'll be going over a question from Knewton.com's Knewton Alta homework system related to the objective: write the parametric equations of a curve in y equals f of x form by eliminating the parameter in linear equations. Okay, so as with most questions I go over in a video, I'd say if you're familiar with the material a bit, you've done a little reading, a little studying, I suggest you pause the video first, look over this question, try to work it out yourself, and then come back and watch me do it and compare your work to mine, see how you're doing. But hopefully watching me go through this one here helps you when you are working on your Knewton Alta homework or any related homework with this similar objective, right? Where you're given parametric equations for some curve, and you're asked to write the rectangular equation, right? The equation in just x and y without the parameter for that same curve. All right, so here we're asked to write the parametric equations below as a rectangular equation. All right, so just an equation for a curve in just y and x by eliminating the parameter. Right, so you see here the x coordinate of whatever location we're at depends on parameter t. So does the y coordinate. Right? Y is a function of this parameter called t as well. X of t is negative 2t plus 2. Y of t is 6t plus 9, right? Both linear equations in t. And you'll notice the way they want us to fill in the answer here is in the form y equals some function of x, and that was also in the title of the objective, right? Y equals f of x, some function of x. All right, and then, the t should be gone here, right? The elimination of the parameter t. All right, so let's show you how we're going to be doing that. So our parametric equations were x of t or just x equals. Again, they have x of t, but I'm going to write it as x equals and then some expression involving the parameter t at negative 2t plus 2 for the x, and then the y, right, y of t, y depended on t in the following way. It was 6 times the value of t plus 9. Now, since they would like, so again, they're asking us to eliminate the parameter, right? Rewrite the equation for whatever this curve is. And I'll show you, and I'll go to that desmos.com site, or you can do it by hand if you want. But we're eliminating t, and they want, the equation, the rectangular equation for the curve in this form, y equals, some function of x, say f of x. So if that's the way they want it, I'm going to leave my second equation where it's already y equals, but it's a function of t. I'm going to replace t with an expression involving just x. All right, so that'll require going back to this equation involving x and t and solve for the parameter t. So I'm going to solve this for t, right? And it's a nice simple linear equation. So that would require, subtracting 2, right? So then you have x minus 2 equals negative 2t, and then dividing everything by negative 2, right? So t would be negative 1/2 x, and then negative 2 divided by negative 2 is plus 1, right? Or you could have x minus 2, all divided by negative 2 if you want to write that. But I'm just going through and dividing each term by negative 2. And then this expression can now replace t in any of the parametric equations here, and we go into the other one, right? The one involving y, and there we go. We'll have an equation for the curve that's traced out by these parametric equations in rectangular form, where it's just y and x. So after that substitution, we'll have y equals, 6 times t, right? But t is replaced by my negative 1/2 x plus 1, and then you got plus 9 after that. And this is great. This is true. This is correct. But of course, they're probably going to want you to simplify things. I know I would. So let's get rid of the parentheses here by distributing the 6, right? We have 6 times all of this. And we're left with finally y equals, 6 times negative 1/2 x would be negative 3x. Then plus 6, but then you have a plus 9 afterwards. Plus 6, plus 9, be plus 15. And here we go. This is what's being asked for right here. All right, so what I'm going to do next is I'm going to go to desmos.com, free online graphing calculator site. And I'll enter our parametric equations in a certain range of values of the parameter t, just to see part of the curve that's traced out by these. And then I'll enter the rectangular equation as well. And we'll see that the curve represented by the rectangular equation involving just x and y is the same curve that's being traced out by the parametric equations for different values of the parameter t. Okay, so here's that Desmos site, desmos.com. So again, first, parametric equations that we were given. Right? To enter parametric equations in the xy plane, you got to enter it as an ordered pair. So left parentheses, and the x coordinate in terms of t was negative 2t plus 2, comma, and the y coordinate in terms of t, y of t was 6t plus 9, close the parentheses, and you'll see it starts off with a range of values of t here. It starts off with just from 0 to 1, so when t equals 0, right, you'd be at this point 2, 9, and then when t equals 1, you'd be at the point 0, 15. So the orientation, I'd be moving from this point here where my cursor is up to where this point is up here, right, as t increases. Now I'm going to go a little larger range of t here. I'll go negative 10 to 10. So when t ranges from negative 10 to 10, we get much more of this line being traced out. But this is the curve being traced out with our parametric equations. Now, after eliminating the parameter, we got this equation, y equals negative 3x plus 15. And see how that curve is right on top of the parametric equations, the curve being traced out by the parametric equations we put up earlier. So they are indeed representing the same curve on the xy plane, where I'm turning it off and on. Hopefully you can see they are right on top of each other. So this is correct then. Y equals negative 3x plus 15 is what they want. That's what I'd fill in the blank here if I was doing this online, doing this for homework. Now they put it the other way, 15 minus 3x, negative 3x plus 15. Same thing, but great. We did it. And in Knewton Alta, once you get something right or wrong, you enter an answer, check it, submit it. It tells you if you're right or wrong. Then there's going to be some sort of explanation afterwards. I would highly recommend reading through those just to see how they're doing things and, can compare it to how you're doing things and see if you're picking up the material well enough. Okay. And that's that for that objective, right? Writing parametric equations in that form with linear equations for your parametric equation. We'll see some other ones. Everything related to this objective is every problem is very similar to this one. So hopefully this helps you when you're working on Knewton Alta on your own. And thank you very much for watching.